A very good afternoon to all. Today I will start with the lecture number 4 for surveying engineering, and it's related to error and its correction in chaining. In the previous classes we have discussed about the process that is chaining, that it is used for measuring the distances, horizontal distances. But while we performing the experiment or while we are measuring the length or width, in that case there may be the possibility that errors can occur. Because obviously if we are using the instrument, there can be the possibility that errors are there. Personal error can be there, that the observer, he or she doesn't know that how to perform the experiment and how to hold the instrument and how to hold the chain and all. And second condition is that in which instrument is having some fault, so obviously errors can be there. So today we will discuss about the different types of error that can be occur in chain. So while we discuss the chain errors, so basically there are two types of error. The first one is compensating error and the second one is cumulative error. Compensating error and cumulative errors are different, so we will discuss one by one. The first one is compensating error. Now what is compensating error? Let me take one example here. Suppose this is the ground and this is the point A and this is point B, and this is the distance that we have to measure A to B, and suppose this distance is too large, we are taking one intermediate point C. Now in the previous classes we have studied about the principle of surveying. So in that case there is one principle that we have to work from whole to part. What it means that we have to start from outer boundary points and we have to move inward direction. So what is this distance? Suppose this total distance is AB and this AB is equal to AC plus CB. Now it will be measured in two parts, A to C and C to B. So what is, if we start the process that we measure the distance from A to C and we place the chain in between A to C. So in this case A to C is done. Now what is, we are starting from this direction. In compensating error, when we are doing the survey from a both direction, in that case what is, errors are minimized or compensate. So now in this case we are measuring the distance from B to C in both direction from whole to part. So what happened, that errors are minimized here because we are working in a both direction. So total distance AB is equal to AC plus CB. So while we perform in such a way to work from whole to part, so such type of errors can occur, that is compensating error, and generally such type of errors do not affect the survey work very seriously, because in this case it is occur in both direction. It can be positive or it can be negative and it can compensate with each other. So it is very minimum impact, it is having a very minimum impact on our values. Okay, so that is compensating error. What are the conditions in which compensating error can occur? The first one is incorrect holding of a chain. If you are not holding a chain properly, obviously errors can be occur there. Second one is horizontal and vertical steps are not being properly maintained during the stepping operations. So that we have discussed in the previous classes also. If we have a slope ground, then how to measure distance. So in that case the technique that we have used is stepping method. Let's suppose this is point A and this is point B, and we have to use step method here, like we have used two step here. So what is this, B, and suppose this point is C and C dash, and this is A dash. So in this case steps will be measured in horizontal direction and then vertical plumber will be dropped on a point, and again then this C point will be stretched up to elevation of a point and A dash point, and then this distance will be measured. So in this case total horizontal distance will be measured. So while we are measuring the slope distance, in this case steps, horizontal and vertical steps are not maintained properly. This can be again give errors. Fractional parts of chain and tape are not being uniform throughout its length. What happens when we store the instruments in the laboratory or in the storeroom? So what happened, that due to temperature or due to some handling errors, what happened, that chains are not properly maintained. In that case there is some parts are missing, like this chain is not properly, suppose it is having not properly stretched, it is having a mingling of links. So in that case what is, again error can be occur when chain is not properly stretched. Now the fourth one is inaccurate measurement of a right angle with a chain and tape. So what is on a ground when we measured a right angle triangle with chain or tape and it is not measured properly, so obviously again there can be a error. So these are the conditions in which cumulative error can occur. Okay, so let me start with the next one, that is cumulative error. Compensating error is very minimum, so we can adjust that one. But if you're approaching towards a cumulative error approach or method, so obviously that is not adopted because it will give you a very large value of errors. Okay, so let's start with the cumulative error. Now what is cumulative error here? Again, starting with example, suppose this is the ground. Instead of approaching from outer point to the inner points, what is A or B, this is the distance AB, we are measuring only in a one single direction, from this direction to this direction. Suppose we have taken this point C, and first we have measured distance from this A to C, and then we measure the distance from C to B. So we are working only in a one direction, so there is a probability that one error that from A to C can get accumulated from C to B. Okay, so when we work only in a one direction, it is having an addition of errors. So when we calculate the total distance AB, it is having a probability that A to C plus C to B. So A to C error addition is also there and C to B error addition also there. So such type of cumulative approach can give a large impact in the calculation. So such type of methods cannot be approached for surveying. So that's why we avoid such type of methods. We always work from whole to part, from outer boundary line to inner parts, like in the previous case, from A to C and from B to C. So such type of techniques are used. Now what are the conditions in which cumulative errors can occur? So we can see here, these are the conditions. The length of the chain or a tape being shorter than the standard length. What is happened that due to temperature in summers or in winters, the actual length of the chain or tape is not maintained because it can be shrink or it can be enlarged. So such type of errors can give a cumulative errors. Next one is slope corrections not being applied. When we measure the distance on a slope, so what is, there is some slope corrections that we'll discuss in the next classes. So that should be also applied. If it is not applied, again it will give you the errors. Now the third one is correction for a sag is not made. What happened that suppose this is the ground and we have this point A and this is point B, and chain is having a little bit elevation and it is hold at this elevation and it is not stretched properly. So what is, if it is not stretched properly, it is having sag. Okay, so that sag is basically what enlarges the value. So again that error is there, positive error is there, correction will be negative. So these are the conditions in which what positive errors can occur and correction will be negative. Measurements with a faulty alignment, obviously if alignment is not done properly. And the last one is measurements are taken in a high wind with a tape in a suspension. Again, if tape is hold in a suspension and it is very windy area, so again it can have a sag issue and obviously it will give you a positive error and correction will be negative. Now next we will discuss with the negative errors. That is the similar condition of cumulative errors. What is, we are working in a same direction. It can have positive or it can be have a negative error. So we have discussed in the previous slide for a positive. Now next we will discuss with the negative errors. If error is negative, correction will be positive. Okay, so that you have to remember. Suppose the opening of the ring joint. What happened that in this case, if rings are not present there and it is opened, so error can be a negative here, correction will be error will be a negative here and correction will be a positive here. The next one is the applied pull being more greater than the standard pull. While we are holding the chain, so what is a one standard pull is mentioned there, that it is from point A to point B. Standard pull will be, if it is extra stretch, so again it can have a error, that is negative error, and obviously its correction will be positive. The third one is due to the rise in a temperature. When there is a rise in a temperature, what happened that your chain length is incorrect, it is more, so obviously error will be a negative, correction will be a positive here. And wearing of our connections means when we talk of about the chain, so it is having a lot of links and connections. So due to a large time, what happened that there is a wearing of connections and it is not properly maintained. And the last one is elongation of links. So these are the all cases when there is a cumulative error conditions will be there. Now next one is chain and tape correction. So these formulas are very important that we have to keep in mind. The correction applied to the length. So always remember this one, that the true length of the line is given by L dash upon L into measured length. What is, suppose if this is the area and we have measured the distance between this 2 point A and B. This is A and B. So this is basically a measured length, and suppose it is given to you 100 meters. So this is a measured length, and it is measured with what? It is measured with a standard length of a chain which is having suppose 30 meter, or sometime it can be a 20 meter. So L is, always remember that L is the standard length of a chain. And what is L dash here? L dash is incorrect length basically here. This is what? Incorrect length of chain. Incorrect length of chain. What is due to elongation and due to shrink, what happened that chain is not of standard length of 30 meter or 20 meter. It is having some errors. So if error is positive, or it can be possible that error can be negative. So these things will be identified and then calculation will be done. So at last what we have to use here, remember that how to calculate the true distance basically, because instrument is not having a standard length of exact 20 meter or 30 meter, because these are the two standard length that is available in the market. So how to get the true length? So true length is equal to L dash, this is incorrect length, divided by L, this is the standard length of a chain, multiply by the measured length. Like in the previous example I have given 100 meters, this is the measured length. So in the measured length we are applying a correction by applying this formula L dash over L. So this will give you the true length of the line. So always remember this formula for the correction. And error in the chain or a tape is represented by E. Okay, remember that how to get the value of L dash. If it is too long, okay, so error will be plus E. Okay, what is L plus E? The standard length plus E. How to get the value of L dash? If it is shrinked, if it is too short, so what is, this is standard length minus E. So you have to always remember these two things in mind, that if it is too long we have to use this formula, if it is too short you have to use this formula, okay, for an incorrect length. So this is how we have to correct the measurement with the help of this formula. Similarly we have to use these things for a area also. So when we are talking about the corrections, the next one is for area. So correct area, how to get area, and we already know what is area is represented by length and width. So what is two dimensions are here? So in that case what we have to do, suppose if it is of a similar length, so what is area is basically a L into L if it is square, so L square is there. So how to get true area? True area is equal to basically A dash divided by A multiply by measured area. Okay, so if directly area is not mentioned, what we have to do, we have to take in terms of dimensions if length and width is given. So what is true area is equal to, it is given in terms of L because it can be rectangle, it can be square, so it depends upon if it is what are the conditions given. So it will be L dash upon L square multiply by measured area. So this is how we have to get the correction for a area. Okay, similarly for volume, that true volume is equal to, obviously it is 3 times length width into height. So what is L dash upon L 3 times multiply by measured volume. Okay, so these are the formulas that you have to remember for corrections value. Now next one is tape correction. Now when we use the tape, what happened that it can be have a temperature corrections, it can be have a sag correction. So first is we will see for a temperature correction. So temperature correction is given by basically this formula, we have to remember it, that correction due to temperature Ct is equal to alpha into Tm minus T0 into L. So what is Ct is correction due to temperature is equal to alpha is basically a coefficient of thermal expansion. It is based on the material, that what type of material we use for a chain or a tape, and Tm is basically a temperature during the measurement in degrees or Celsius. This is the measured temperature basically while we are doing the survey, and T0 is basically a standard temperature that will be given in degree Celsius, and L is the length of the tape in a meter. So this is how we have to do the correction for a temperature also, because if standard temperature is not there, so this error can be over positive or negative. It depends upon that which value is greater. If measured value is greater, then obviously it is having positive error, and if standard temperature is more and measured temperature is less, so obviously in that case what corrections will be negative. So this is the tape corrections. Now next one is tape correction for a pull correction. So in case of pull correction, what is that, like I have already given the example. Suppose this is point A and suppose this is point B, and we are holding a chain or a tape here, and what is if it is extra pulled, it is having an extra pressure on it, so again it is having a change in a values also. So pull is also having an impact on our errors. So how to do the pull correction? So pull correction is given by this formula. Pull correction is basically depending upon the pull applied during the measurement. What is Pm is representing pull, representing a pull during a measurement, minus P0 is the standard pull that we have to apply, multiply by the length of the tape, divided by A, that is the cross sectional area of the tape, multiply by E, that is modulus of elasticity. So while we are discussing about the pull correction, in case of pull correction, this formula is used, that correction due to pull is equal to Pm is basically a pull applied during the measurement, and P0 is the standard pull, and L is the length of the tape, and A is the basically cross sectional area of a tape, and E is the modulus of elasticity. Again it depends upon the tape material, that what type of material is used for tape. So this type of correction is applied for a tape. Okay, so this is the correction due to pull. Now next one is slope correction. What is slope correction? Like we have seen here, that this is the triangle that we have used here. This is A, B and C, and this correction is basically what CH here, and this is the height between the 2 points, and this is the slope distance between the 2 points, and this is the angle theta. So in this case, how to get this slope correction? Slope correction is basically given by the formula, this formula. Again, trigonometry will be used here. Exactly corrections are given here, CH. So this slope correction is given by CH here, and using a Pythagoras theorem, what we have to calculate this part here. So this is L minus root of L square minus H square, and in second term slope correction will be used by this formula also, that CH is equal to L into 1 minus cos theta, and the third formula is it can use in this formula, that slope correction is equal to H square upon 2L. So these three formula that you have to use for the correction of a slope. Okay, now sag correction, I have already explained that if these are the 2 points, suppose this is point A and this is point B, and if tape is hold at a elevation and it is not hold properly, it is having a sag, this sag. So in that case, what is again Sag corrections will be applied, because it is giving you the larger value, obviously it's correction. So Sag correction is always negative. Remember this thing in mind, that Sag correction is always negative. And in the previous case, slope correction is again also always negative. Okay, so these things you have to always remember, that slope correction is always negative because it increases the value, so obviously correction will be negative. Or again, Sag is positive error, so it will giving the correction will be negative correction. So how to do the corrections for a Sag? So it is given by this formula, that Sag correction is represented by CS here, that is L into W into L square divided by 24 N square PM square. And what are the basic conditions here? That L is the length of the tape, W is the weight of the tape per unit length. Remember that sometime capital W will be given and sometimes small w will be given. If small w, so it is weight of the tape per unit length, you have to multiply by L here, then you will get the total weight of the chain. So W into L, you have to do it square, divided by 24 N square. What is N here? N is the number of span. What is sagging is that how many spans are there in between, and M is basically a pull applied in kilograms. So this is the basic formula for a Sag correction, and Sag correction is always negative because Sag is always giving you positive error, so correction will be negative. So these are the things you have to remember. So these are the different types of error that we have discussed in case of chain surveying. Now in the next class we will do some numerical on the corrections and the errors. So we will meet you in the next class. Thank you.